Hi guys, let's learn about vectors. So vectors are very important. Without the knowledge of vector, nowadays it's very difficult to locate the position of aeroplane or satellite or any kind of the object. So let us try to learn in detail about vectors. So we know about physical quantities are divided into two categories. One is scalar, another one is vector. So scalar is any quantity in physics that has only magnitude. So magnitude here means nothing but a numerical value, maybe plus or minus. Suppose if you say what is your height, how you can describe? So your height is maybe 6 feet. The 6 here itself is the magnitude. And what is your weight? Maybe 60. So that 60 itself is a number. So scalar is physical quantity which represents only magnitude, just like height, weight. But a vector is any quantity in physics that has both magnitude and direction. So in physics, direction is very important. If you neglect the direction, we will be in stuck up to find out the resultants. So the physical quantities which have both magnitude and direction are known as vectors. So some scalars, speed is a scalar, distance is also a scalar, and your age and how much energy you are spending, that energy here is also a scalar, and power, it's also a scalar. So these are some of scalars which requires to specify a scalar only magnitude. But some physical quantities, so like displacement according to definition, the shortest distance between initial and final position. So the displacement should represent with the magnitude and direction. Like velocity is displacement upon time. So if displacement is a vector, velocity too also a vector. And force and acceleration. So when we deal with these physical quantities, especially vectors, so we need to think much more carefully about its direction. So how we represent vectors? The very easy and better representation of a vector is with an arrow. So a picture is worth 1,000 words, at least they say so. So vectors typically illustrated by drawing an arrow above the symbol. Suppose if you take this bug is moving from one point to another point. So this is initial and starting position, and this is final position. To find out the displacement, what we define displacement? Displacement is nothing but the shortest distance between A and B. So the displacement is nothing but, if you draw an arrow, so this arrow is vector which represents displacement. So to this arrow, the starting point we represent with the tail of an arrow, and ending point we represent that head of an arrow. So the length of the vector represents the magnitude, and the direction is represents in which direction it is moving along with particular reference axis. Here reference axis we take as x-axis. So the vector is moving along x-axis with making an angle of 25 degrees. Suppose if I make this as a reference axis, this vector, that bug is moving with respect to reference axis. To represent position we need to depends upon the reference axis. So this is how the displacement is represented with the help of a vector. So the first vector is displacement. Here the length of the arrow represents the magnitude of the vector, and the direction, the direction here we need to specify. So the specified direction here, the displacement x bar equal to 6 centimeter and 25 degree. So the vector's magnitude is always positive, and it is the length with units. So when we represent vectors, be careful. So the vectors comes always a positive sign, and here the unit must be represented, and rest of that represents about its direction. Suppose if vector represents negative sign, so it tells about it is moving in opposite direction. So that's also you can see. Let us see one example. Example of a vector velocity of a plane. So here we will try to find the resultant velocity. Since velocity sometimes it can be added, combined. Let us take a situation. A small plane is heading south at a speed of 200 km per hour. So in this special case, if we take, if there was no wind, plane's velocity would be 200 kilometers per south. So that is the velocity of the plane with 200 kilometers per hour. It is heading towards to south. So here if we can draw that news northwest, northeast, west, south. So the plane is heading towards south because we need to represent that with a direction. Now if a plane encounters a tailwind of 80 km per hour, tailwind means the wind which is pushing from backwards. So when plane is moving with 200 km per hour, from back side a tailwind 80 km per hour. Now here the one is plane velocity, another one is wind velocity. Now they both are having magnitude and they both are having direction. Yeah, they both are representing south, towards to south direction. What could be the resultant? So in this case, the plane will move with the same velocity or greater velocity. Or you apply this case, suppose you are walking, take a situation, you are running. Somebody came from behind and they push you. What happens to your velocity? Yeah, obviously increases because they applied force. So here the tailwind is 80 km per hour, also applied a force on the plane. So the total velocity of the plane here is 280 km per hour. So now this time the plane gaining velocity because of the tailwind. So here how we got it? Literally we added velocity of the plane with the velocity of the wind. So that's the reason here we got 280 km per hour. Did you notice any change in the direction of the plane? No, there is no change in the direction of the plane because wind velocity and plane velocity, they both are acting in the same direction. Suppose we take a situation, if it's landing to Bangalore, if the wind changes direction suddenly 180 degrees, so it means in the earlier case it is flowing in towards the south direction. Now in this case it is flowing towards the north direction. Now wind direction is 80 km per hour, which is opposite to the plane direction, plane velocity direction. Now wind is blowing towards north direction. Now in this case, what is the resultant velocity of the plane? Yeah, in this case the resultant velocity of the plane is decreases, that is 120 km per hour. Here how the plane velocity decreased? Because the wind velocity which is acting opposite direction to the plane velocity. So we need to subtract that, the resultant velocity. So here you got the understand how the velocity direction is responsible for changing the velocity of the plane. Now flying against 80 km per hour wind, the plane travels only 120 km per hour. So that is related to some with reference to some ground axis. Suppose if we take different wind directions. So in the first case, it is 200 km, there is no wind is acting. In the second case, from the tailwind which is acting from the backward. From third case, the wind is acting opposite to the plane velocity. In the fourth case, the wind is acting perpendicularly. So wind direction and plane direction is perpendicular. And in the fifth case, some arbitrary angle you take. So these are the different directions of wind. So in this case, there is no wind, but in this case, the wind is acting in this forward direction. Now if you can notice the speed of the plane. Now in all the cases, the speed of the plane is, the velocity of the plane is different. What could be the cause? Here the cause is, in all situations, the velocity of the wind is different in different directions. So let me play that one more time to you. So if you take at different random velocities at here no wind, no tailwind, but here tailwind is acting in the same direction towards to the north, but here it is acting opposite to the plane velocity, at here perpendicular to the plane velocity, at here you take any one arbitrary angle. So because of this velocity at different wind velocity, that causes the plane velocity. So literally this example shows how this velocity is very important factor, especially the wind velocity is playing very important role. So let us try to learn much more about vectors. So as per we saw, vectors are represented with an arrow, the length of the vector drawn in terms of particular scale, particular units, and the length of the vector represents the magnitude of the vector quantity, and the direction will represents with respect to angle with respect to reference axis. So the direction vector is the angle which the vector makes with the x-axis or east axis toward to east. So that we make as reference axis. Now here we can see a vector is rotating. So the rotation of vector is showing in terms of degrees. So that degrees we are representing with respect to a reference axis. Here if you take my reference axis across it here, so that is the reference axis. So with respect to reference axis, the angle at here showing, it is around 270 degrees. Now you can see the reference angle shows with respect to x-axis. So like this, the magnitude of the vector is represents the length of the vector and the direction. So the direction will represent with respect to reference axis. So here reference axis we will take along the x-axis, or in terms of direction we will take that east direction. Now let us discuss much more about these vectors. So if you can see here, these vectors are equal in magnitude and all are same in direction. So if two or more vectors are equal if they have same magnitude and the same direction. So this is the same vector, so it does not matter where it is, only can move or transit or rotate. It determines only by magnitude and direction, not by the starting point. So we can say these vectors are equal vectors. Equal vectors are nothing but they should have equal magnitude. See, these vectors all are having equal in magnitude and they should represent in the same direction. Then we can say those vectors are known as equal vectors. So don't bother about equal vectors, they all should have same starting point, not necessary. So they can be anywhere in the given plane. Not necessary that they should start with the same reference point, not like that. They can be anywhere in the plane, but only condition is that when you say two vectors are equal, they equal in magnitude and same in the direction, then we can say those vectors are known as equal vectors. Now what happens if you take a vector and multiply with a scalar? Multiplying vector by a scalar. Suppose I am having a vector. So let me take a vector. Here a bar is a vector. I am multiplying a bar with a number. Let that number be 2. So 2 into a bar, it becomes 2a bar. Yeah. Now here a bar and 2a bar both are two vectors and they both represent same direction, but the magnitude of the vector is different. And if you multiply that with another scalar 3, so that represents 3 vectors. Or if you multiply with any number, so that number decreases the magnitude of the vector. So it means we can multiply a vector with a scalar. Vector multiplies with a scalar or a number. Suppose 3 meter per second is a vector, velocity is a vector. If you are multiplying that with a scalar of 2, so the total value will become 6 meter per second. So if the 6 meter per second if you take as a vector, so this 6 meter per second the magnitude will increases. If this is 3, so the next vector will becomes doubles. So I need to draw twice of the length of the vectors. So this is 6 meter per second. So we can multiply a vector with a scalar. Then the direction of the vector it won't change, but its magnitude will change. What about if you multiply a vector with a negative scalar? Suppose I am multiplying a bar. So I am multiplying a bar with a negative number. A bar times -1. What this value is supposed to write? So I can write minus a bar. So how we can represent minus a bar? If this is a bar, minus a bar is nothing but just flip the vector of the same magnitude but opposite in direction, and this vector becomes negative vector. So a vector magnitude never be negative. If it is showing negative sign, it means it reverses its direction. So whichever the vector is representing its negative vector, it means its direction is opposite. So this is the reason if multiply a vector with a negative number -1, so that does not change the magnitude of the vector, but it changes its direction. So these two vectors are known as opposite vectors. They both are equal in magnitude but opposite in direction. So likely if we can multiply with a negative and more in number, so the length of the vector is increases but the direction also will changes. So this is how a positive vectors and how a negative vectors will change its direction, and if you multiply with a scalar. Now addition of a vectors. We need to add two vectors just like in the plane. In the plane example, if the tailwind velocity and velocity of the plane in the same direction, we added that two vectors. So here to add two vectors, we are following certain methods or certain rules. Sometimes if vectors are the more than two, we need to use certain laws. Let me take two simple vectors. Suppose this is A bar and this is B bar. Now I need to add A bar plus B bar. This A bar and B bar, this is B bar and this is A bar. So we can add two vectors by head and tail method. Head and tail method. Each vector having its head, so this arrow mark represents head and the back side represents tail. Now to add two vectors, the second vector tail should bring to the first vector head. Now in this case, if we can add these two vectors, we need to bring the second vector tail. So this is the head of the second vector and this is the tail of the second vector. So we need to bring the second vector tail to the first vector head. Wherever it is in the plane, you can move the vectors and you should not change the direction. Without changing the direction, you can move the vectors within the plane. You should not change not even 0.0001 degree. If you change the direction, the resultant direction will be changes. Just move the vector as it is. Now these two vectors, head and tail, are combined at here. Now to draw the resultant vector, so we can draw the resultant vector from tail of the first vector to the head of the second vector. So the resultant of these two vectors will becomes S. So here S bar equal to resultant of A bar plus B bar. So this is the way to add if two vectors are given by not using any kind of the laws. Later we will introduce some kind of the laws. So with the help of some rules and laws, we will add very easily. So this method we known as head and tail method. Head and tail method is very useful to add two or more vectors. So how we can add? We just move the second vector tail towards to the first vector head. So if A bar and B bar are the two vectors, this is A bar and this is B bar, and if we need to add B bar to A bar, just move B bar towards to A bar without changing its direction, and now combine the tail of the first vector to head of the second vector. Now that gives the resultant. Now S bar equal to A bar plus B bar. Suppose if you want to add B bar to A bar, so in the first case it's added that A bar to B bar, so we need to add B bar to A bar, both gets the same. So in the second example, suppose if we can add that, if you take A bar, so this is two vectors adding A bar to B bar. So in the second, if you are adding B bar to A bar, So move the B bar vector. Suppose this is B bar and this is A bar. Now in this case I need to move A bar vector towards to B bar. So this is the A bar. If it is B bar and I am moving in the A bar to get the resultant. Now in this case to find the resultant, resultant also same. So the resultant is in the same direction. So this is A bar plus B bar plus A bar. So if we add A bar to B bar or B bar to A bar, so they both will be same. A bar plus B bar equal to B bar plus A bar. This is something like called as commutative law of addition. So vectors follows this law. So anyway you can add it, there is no problem. But keep in mind that we should not change the direction. So vectors can be moved around as long as their length and directions are not changed. And vectors that have the same magnitude and the same directions are the same. So like that, if we can add multiple vectors, so we can find the resultant. First vector to second vector, second to third, third to fourth, and fourth to 5. So you can move the vectors from head to tail method. So find the resultant vectors. So let us take a situation at here to represent the vectors. Suppose I am a pirate. So I started at here to find some treasure. So first I moved along this direction, that is A bar. Then after I move along the B bar direction, and that is the end. So this is starting point, and that is ending point. So but to move A bar and B bar to the end, it takes a long time. But if I know how to add this A bar to B bar, instead of moving from A to B and again B to end, so I can move directly from the starting to end. So that gives the resultant displacement direction. So here if we know how to add that from one location to another location, directly we can add it and we can get that advantage of the addition of vectors. Instead of moving from all way from here to there and there to there, we can directly add that too and we can get the final resultant. So this will help us to find the displacement S. So let us try to subtract the vectors. Suppose this is A bar one vector and B bar. So try to find the A bar minus B bar. So to find the A bar minus B bar, so we need to add the head and tail method. So first vector A bar and bring close to the second vector B bar. And to represent the, here we are having minus B bar. So minus B bar is the same vector but in the opposite direction. So B bar direction should change. Now in this case A bar and minus B bar, now you can add that A bar plus minus B bar. So this gives the resultant of vector which is equal to C bar. So here minus B bar is the opposite direction of the vector B bar. So this is how we subtract vectors. So again a reminder, vectors do not have negative sign. So negative sign means that is opposite to the direction of vectors. Now let us try to guess a question which is given here. The diagram below shows two vectors x and y. Find the vectors x plus y. So to do that, try to draw, sketch it. So this is an x bar, this is a vector, and you bring the y bar vector to the tail of the first vector. Suppose if I bring the y bar, so y bar is along in this direction. So this is y bar. And now I need to find that c equal to x plus y. So now I need to draw the c bar vectors. Yeah, this is the c equal to x plus y. What is the answer? The answer is B portion. So we can add like that y bar and we can get the c equal to x plus y. So B is answer. So try to do more practice so that we can get more knowledge how to add the vectors. Let's take one more problem. Here two vectors are given. Try to find x minus y. So this is x vector. Now this is x vector and minus y. If this is y and change its direction, take the mirror image. So if you take the mirror image, the vector gets flipped. So while flipping, be careful, the head and tail position should not change. In the place of head of the second vector, you bring the tail, just flip it. Now if you can add these two, x and y, so that gives that x minus y. So that is the resultant vector. Again in this the answer goes to B. So this is how we add and subtract vectors in simple manner. So this method known as head and tail method. Let us learn different types of vectors.